Have you ever seen these before? Do you know what they're called? They're called algebra tiles. And I've got 3 sizes here, so you can see them all. Okay? Got 3 sizes here. I need to make sure you understand what they all mean so that they make sense in this demonstration I have for you right now. Okay? The length of this side right here, we're going to call x. Okay? So if the length of this side is right here and this is a square, what's the area of this? X squared, right? X squared. We okay with that? Okay? What do you think the length of this side is? Right here. X, right? It's the same length as this, isn't it? So it should have the same length, right? What length is this side right here? 1. How do you know that? Because you already used these. Excellent. Okay. So then what's the area of that one? 1x or just x, right? Okay. What's the area of this one? How do you know it's 1? That side is 1, so that means that side is 1, and so is that one, right? So the area is 1. So everybody understand what each of these represent? Okay, so here's what's going to happen today. I'm going to give you an x squared, and then I'm going to give you, let's say, that many. 6. 6 x's. And I'm going to say to you, can you make a square? Can you? How would you go about making a square? Just like putting them next to each other? That doesn't really work. That's closer, but still doesn't work, does it? Because it's not a square. What do you think? What if I did that? Is that a square? Is it closer than we've been before? What do I need? I need some little baby ones for right here, right? How many? How do you know it's 9? 3 times 3? Is that a square? Well, we don't want to look at it, because even in geometry you decide you can't just assume by looking, right? Well, if it's a square that has the same length of sides all the way around, right? What's the length of this part right here? X. And what's the length of each of these? 1. So the length of this side is x plus 3, right? Okay, so what's the length of this side? X plus 3. What's the length of this side? Ooh, x plus 3 and this one? Did we just prove it's a square? Yes, so is this a square? Okay, so here's the deal though. All I gave you was that. And in fact, if you want to get technical, that's what I gave you, right? I think it was even at an angle. How are you going to figure out how many little baby ones that we need to add based on how many x's I give you? Well, what did you do? What did we do with these? We split them in half, right? We put half over here and half over here. What was left to fill in right down here? Isn't that a square? And then what did we do with that number? Multiplied it by itself, right? To figure out how many of these little baby ones. So, what if I gave you 8? What would you do? You'd split that in half. So 4 here and 4 here. How many baby ones would we need? 16. How do you know 16? 4 times 4. Okay, what if I gave you 12? What would you do first? Split those in half. Here and here. $36. And how'd you get 36? 6 and 6. So what if I gave you 20? Oh no, I don't have 20. Oh gosh, we're just going to have to think about this one. What would you do? How many would go here and here? 10 each. So how many baby ones would we add? 100. Okay. So do you think there's a way we can talk through that algebraically now? Okay. So first of all, I said, what, 6x? I gave you x squared and 6x. And how many did we add? 9, because we took the 6 x's and we split them into two parts. We halved it. And then what did we do with that number? Multiply it by itself. Okay, so 6 divided by 2 is 3, and then 3 times 3 is 9. Okay, and then I said 8, right? And what do we do with this 8? Split it in half, and then multiply it by itself. So splitting this in half gives us 4, and then multiplying it by itself, 16. And then I gave you a hard one. I gave you 12. And how many did we add? We split this in half, and we added 36, right? Because we split the 12 in half, and then we times it by itself. So can we get a little bit more technical with our vocabulary here? So then I said x squared plus 20x. What did I do with this number? Okay, so I divided it by 2, right? Again, we're getting a little bit more technical with our vocabulary. I divided it by 2 and got 10. And then what did I do with that 10? I squared it. 100. So do you understand how you might complete the square? You understand geometrical? I'm just making up words, I'm sorry. You understand geometrically what's happening, right? We're literally trying to complete the square we were making with the algebra tiles, right? Algebraically, do you understand what we're doing? We're completing this to make this a perfect square trinomial. Okay? You'll see why in a second, I promise, but we have to get this down first. Can I try to trick you? Okay? What about x squared? Well, I can't trick you because I already messed up. So let's just do x squared plus, 22x. That seems difficult, right? So dividing it by 2 gives me an 11 squared is 121. Now let me see if I can trick you. Ready? Are you positive? You're really positive that we would add 49? What's this divided by 2? Negative 7. Negative 7 squared. You're positive that it's positive 49. We're squaring it. Yeah, we took whatever this is, dividing it by 2, and then we're squaring that number, which means I'm multiplying it by itself. So you're saying to me negative 7 times negative 7 is positive 49. And you're positive about that. Good. I need you to be positive. Will we ever subtract anything right here when I'm completing the square? No. Because if it's a positive number and I square a positive number, I get a positive number. But if it's a negative number and I square a negative number, I still get a positive number. Does everybody understand that? Good. I just need you to be positive about it. Okay? I need you to be sure, I guess I should say. Okay? So, just to be clear on your homework, it's going to be super confusing. And it's going to say something like this. X squared minus 10x plus c. What is the value of c? And you're going to say c equals 25. And then go to the next problem. You okay with that? Okay. So what I found in today's lesson is if we'll take it little steps at a time, we're good. So that's the first step. Are you okay with the first step? Okay, so can we try the second step? Yes, ma'am. Where did I get 25? Can somebody help her? Take this, divide it by 2, and square it, just like I did on every other single problem. Take the x term, divide it by 2, and square that number. Negative 10 divided by 2 is negative 5. Negative 5 squared is 25. Good? You sure? All right. Are you ready for the next little step? It's just a little tiny step. Okay? We have purposely made these into perfect squared trinomials. Do you notice that? I would like to factor this first trinomial. What multiplies to be 9 and adds to be 6? 3 and 3? So how could I write that? X plus 3 times x plus 3? So you want to say x plus 3 squared. In fact, we really, really want to do that. Not only could we really want to do that. Yes, we are going to do that. Okay? Could you factor the second one? What multiplies to be 16 and adds to be 8? 4 and 4, so x plus 4 squared. Now, you guys have gotten pretty good at factoring, so I know you're comfortable with factoring, but is there a quicker way than to think of it as factoring? Factoring is not wrong. Please understand that. That's what we're actually doing. But is there a quicker way to get to our factors? I could just do half of the middle term. Could I also do the square root of the last term? So what would this be? X plus 6 squared. What would this one be? X plus 10 squared. What would this one be? X plus 11 squared. Dun dun dun. What would this one be? X minus 7 squared. This matters now, doesn't it? The sign matters. We took that sign from that middle term. We can't really take the sign from the last term if we're taking a square root of it because it's just 7, right? We have to look and pay attention to what that sign of the middle number is. So here it might be a little more secure to say what multiplies to be 49 and adds to be negative 14. Oh, that's negative 7. You good with that? Just for good measure, let's do the last one. X minus 5 squared. How are you feeling? Okay. So, can we do the next step? The next step is really, really easy. Because the next thing we're going to have to be able to do is we're going to have to take the square root of that. What is it? X plus 3. Can you take the square root of this one? X plus 4. Can you take the square root of this one? X plus 6. You guys never believe me when I tell you stuff is easy. What about this one? X plus 10. What about this one? X plus 11. What about this one? X minus 7. And the last one? X minus 5. Right? Can you do these 3 steps in a row? Okay, then we almost have it made. You ready? Here's what you're going to be asked to do. Here's a problem in total. Okay? Here's a problem in total. X squared plus 6x minus 17 equals 0. Now, somebody in the last period class goes, wait a second, you're teaching us another way to solve quadratics? Guys, by the time we're done with it, I'm going to teach you 6 or 7 ways to solve quadratics. I already taught you 3 ways yesterday. Now today is another one. Okay, we're going to solve this quadratic by completing the square. Why in the world would I teach you 6 or 7 ways to solve one kind of problem? Some of them are easier than others. Some of them you'll feel more comfortable with doing, so it works best for you. Okay, is there a way that works every single time? Yes. Is it always the easiest? No. Okay, so if there's some easier ways, I want to teach them to you. But please understand, we will be learning a way that works every single time. No questions, no doubts, no nothing. Okay? So, you ready for the steps on how to do this? Okay, the very first step is I need to get rid of the constant. Okay? It's in my way. It's not part of me completing the square, so I need to get rid of it. I'm going to move it to the other side of the equal sign. Okay? Now, it's kind of opposite of what we've been doing in some of our other ones, because the other ones we want to get it equal to 0, don't we? Well, this is set up, and I decide I want to solve it by completing the square, so the first thing I do is move the 17. Okay? X squared plus 6x equals 17. Do you see what I did? I left a space. I actually draw myself a blank because I don't like to leave blanks. I want to fill in that blank. What's going to go in that blank? What? Is it? Plus 9. Everybody agrees? Because you said 6 divided by 2 was 3 and 3 squared? Perfect. Except now I've just changed the problem. And that's unacceptable. That's a good guess, but we're not there yet. Keep that in mind. Guys, if I add 9 to one side of the problem, that has completely changed the problem. It's unacceptable. Is there a way to fix that? Add it to both sides. So actually, when I draw my blanks, I draw one on either side of the equal sign so I don't forget to add it to the other side. Does that make sense? Now, what do you think is our next step? Binomial. Okay, what's the binomial of this trinomial? X plus 3 squared, remember? Equals 26. These are like problems we did yesterday. How do I solve something that's being squared? Square root it. Both sides, right? What's on the left-hand side? What's left? X plus 3. What's left on the right-hand side? Please don't forget. Please don't forget. Plus or minus the square root of 26. Because I don't know the square root of 26. If it was 25, I got that, but I don't know 26. Okay? Guys, what do I have left to do to solve for x? Subtract 3. X equals? You know what this super crazy kid earlier said? Plus or minus the square root of 23. And then I cried. Not really, I didn't cry. I haven't cried today. Not the whole day. Why can't we put the negative 3 inside the root? Yeah, you just can't do that. It's against the square root rules. The square root police will come for you. You got to watch out. Those square root police they're crazy. Okay? You want to stay away from them. They're not like the good police. They're the square root police. And if they come, that means you did something not good. Okay? Guys, that's the answer. We're done. You ready for the next one? Okay. X squared minus 10x plus 16 equals 0. What would you like to do first? So subtract 16 from both sides. So x squared minus 10x equals negative 16. I'm going to draw myself 2 blanks. What's going to go in the blank? 25. So plus 25 plus 25. What do I do next on the left-hand side? Binomial. What is the binomial? X minus 5. Very good. Squared. Equals? 9. Yeah, 9. Okay, good. Now what? Square root both sides. X minus 5 equals? Try again. Plus or minus 3. Good. Now, be careful. What do you do to solve it? Add 5. X equals what? You would have to do 2 problems, wouldn't you? You would do 3 plus 5, which is correct. You guys are 8. And then, what's negative 3 plus 5? 2. I got 2 answers. Well, guys, I got 2 answers up here, didn't I? Negative 3 plus the square root of 26 and negative 3 minus the square root of 26. I just didn't do that calculation because I don't know the square root of 26. I know it's a little bit more than 5, but I don't know exactly what it is. And right now, I don't care. This is enough for us right now. Okay? This one, I do know the square root of 9. I got it. It's plus or minus 3. So I do each part. 3 plus 5 is 8. Negative 3 plus 5 is 2. Please don't make the mistake of adding 5 and getting plus or minus 8. Please don't do that. Okay? Any questions? Another one. What? Yeah, they both are. It's a quadratic. You should get 2 answers. But yes, you should go back and check it. Here's the deal, guys. These are hard to go back and check, aren't they? How could we check this? We could graph this and see where it crosses the x-axis, couldn't we? Wouldn't that help? How could we check this? We could just plug these in, right? 8 squared is 64. 64 minus 60. Is that what I want to say? 8 times 8 is 64. 8 times, oh, how about 80? That helps. 64 minus 80 is negative 16 plus 16. Is that 0? Then 8 is correct. What about 2? 4 squared? I do that all the time. I'm sorry. 2 squared is 4. 4 minus 20? Negative 16 plus 16. So do they both work? Good job. X squared plus 12x plus 47 equals 0. Subtract 47. Very good. Why did I put my 4 and 7 so far apart? That's weird. X squared plus 12x equals negative 47. So I'm going to give myself a blank on either side. It is correct. That is 36. On the left-hand side, what do we get? X plus 6 squared. Why did I do that? So weird. Negative 11. Okay. Now what? Good. Good. Left-hand side? X plus 6. Right-hand side? Plus or minus? Do we leave negatives inside of square roots? What do we do instead? Guys, what's the square root of negative 1? I. What's the square root of 11? I don't know either. Done. Don't forget about that. You better not forget about that. Okay. How do I solve for x? Subtract 6 from both sides. X equals? Very good. Very good. Now, guys, what's true about every single problem that we've done so far in relation to the leading coefficient? They're all 1. On purpose? Yeah. It doesn't. We don't complete the square unless the leading coefficient's 1. So what happens if the leading coefficient is not 1? We don't give up. You have some on your homework like this. We need to know what to do. Yeah, we should. We should just divide everything by 3. In this case, because the 3 is the leading coefficient. X squared plus 3x minus 16 over 3 equals 0. Could you go from there if I asked you to? I'm not going to ask you to right now. I just wanted to have the discussion with you of what to do. You okay with that? Any questions on this? Completing the square. Feeling comfortable? If you do have questions, what should you do? Ask. Excellent. Okay, tutorials is also an option. Yeah? Okay, peace.